Hello everyone. So in the last lecture we have seen the operations on the scalars and vector, how a vector is represented, what are the different methods of adding or subtracting the vectors. This is all what we have seen in the last lecture, and I had told you that vectors are more used in the context of 2D motion. So we will see how to apply these basics of vectors while analyzing the problems in 2D motion. Let us take a basic simple problem in 2D motion, wherein you have now, since it is a 2D motion, earlier in 1D motion you can now notice a difference. In 1D motion we had only a single line over which the motion was taking place. In 2D you will have, along with x, you will have a y direction, and the motion will take place not on a line but in fact on this xy plane. The motion will take place on this xy plane. So let us say that you have a particle here at a location, say 2, 2. So x is 2 and y is also 2. Here lies a particle. This is its initial position. The particle starts moving in vertically y direction. It moves to a point 2, 4, which is point B. So first point A is 2, 2. That means on x and y axis it is at 2, 2 location. Then it moves upward. So only its y coordinate will increase to 4, whereas x coordinate will stay at 2. So that is my point B. And then it moves horizontally to point C, which has coordinates 4, 4. So on x axis it is 4, on y axis it is 4. So this is the path that the particle has taken. So while it was moving on path AB, its speed of motion was, let us say, 2 meters per second. And when it was moving on path BC, its speed is 1 meter per second. So you can say that motion AB is in north direction and motion BC is in east direction. If we take our usual sign conventions, this is north, this is our east, this is west, and this is south. So we have a motion that is taking place northward and then eastward. Okay. Now if I ask you, tell me the total distance covered, displacement, average speed and average velocity. The same 4 terminologies that we dealt with in 1D kinematics. Tell me all those 4 things in this 2-dimensional motion. Then what will you do? Apply the same basic knowledge. What is your distance? Distance is the length of the path that is covered. Now length of the path, let us say x and y axis both are in meters. So x axis is in meter, y axis is also measured in meter. So when I say 2, it is 2 meter. When I say 4, it is 4 meter. Same goes with the y axis as well. Now how much is the total length of the path covered? It is AB plus BC. So I can give distance as length of the path covered, that is the length of AB plus BC. How much will it be? In AB direction it is 2 meter, in BC direction it is 2 meter. Now for distance we are not concerned with the direction of the motion, and that is why even though one distance covered is in north direction whereas the rest is in east direction, I am not bothered about the sign of the distance. And that is why I can directly write it as 2 meter plus 2 meter, irrespective of or not bothering about the sign of it. Like we have seen in vectors, the x direction is represented by a unit vector I cap, whereas y direction is represented by a unit vector j cap. But I am not attaching I cap and j cap with these numbers 2 and 2 because it is merely a distance that is covered. So it will be a scalar number. And that is why the answer comes as distance covered is 4 meter. Okay. Now the displacement. Displacement, you can find it in 2 ways. The first way, in fact both the ways, they mean one and the same thing. They have a minute difference in how you find it. First way of finding it goes through the definition. How have we defined our displacement? We have defined it as a change in the position, where change is defined as final position minus initial position. So what is your final position? It is here. which is point C, 4 comma 4. What is your initial position? It is point A, which is 2 comma 2. What is the intermediate position? Though we are not bothered about intermediate position while we are defining displacement, but let me just write it. It is 2 comma 4 is the intermediate location that we covered on the way in our journey. Now the displacement is net change in the position. So what was your initial position? It was here. What was your final position? It is here. That means how much is the net change? It is final position minus initial position. How much is it? Now for to calculate it, you should know a distance formula. So you have this as one position coordinate, this as another position coordinate. Through distance formula you can find it. That is one way. So distance formula is something like this: square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Just subtract their xx and yy coordinates, square them, add them and take a square root. This is one way. Second way is even more intuitive. You construct and make it a right angle triangle. Right? Can you see this shaded right angle triangle? Now what will be the base of this right angle triangle? It is the difference between 4 and 2. That means the base of this right angle triangle is 2 meter. How much is the height? Again the difference between 4 and 2. So it is 2 meter. So what will be the hypotenuse? That means A to C. What will be this distance? It will be square root of 2 square plus 2 square. Because what does the Pythagoras theorem tell us? It tells us that hypotenuse is square root of sum of the sides, sum of the squares of the sides. So it is square root of 2 square plus 2 square, which is square root of 4 plus 4, which is root 8. Even if you plug in these values for x2 and x1, you use this is point number 2. So x2 will be 4, x1 will be 2. Here y2 will be 4, y1 will be 2. You plug in these values, you will get the same answer. This is another way of doing it. Third way of doing it is through vectors, because now we have learned vectors. So, we can use that knowledge about the vectors in finding this displacement. Now again, for vector, we know that displacement is the change in the position, or now we have learned, when we learned vector, we learned that displacement and position both are vectors. Right? So can I not write it as displacement vector is equal to change in the position vector? Right? Now once I write that, it means final position vector minus initial position. Right? Final position vector minus initial position. Now how do I represent my final position vector? Where is your final position? It is at point C. Where is your origin? It is here, 0, 0. Okay, let me just clear this figure a bit so that you will understand the third way better. And since third way involves use of vectors, it is more important to learn how to use it. So this is your final position C. This is your initial position A. Okay. Now, what is your final position vector? How will it look like? This is how final position vector will look like, right? How will your initial position vector look like? This is how your initial, let me draw it with some other color so that you can see it. This is how your initial position vector will look like. Now, I just want to find the change in the final position minus change in the initial, the change between final and initial positions using the vector. So what is the vector that will represent our final position? We have learned in the previous lecture the ways of representing a vector, and there were two ways of doing that. One is the polar form, which needs the length of the vector and the angle of the vector. The second form is a Cartesian form, which represents a vector in its x component and y component form, where x component is attached with I cap, y component is attached with j cap. So how will I represent? Let us say I want to represent it in Cartesian form. So how will I represent my final vector? It will be 4 I cap plus 4 j cap, because it is 4 in x direction and 4 in y direction. So I will write it as 4 I cap plus 4 j cap. minus. How will I represent this red colored initial vector? It will be 2i cap plus 2j cap. So it is 2i cap plus 2j cap. What is the result of this subtraction? Subtract I cap related things and j cap related things. So that will give me 2i cap plus 2j cap. Right? This is my final answer. This is how I can represent my displacement vector. So vector is giving me some more information about the displacement that has happened. And what is that more information? Even our previous methods could have given me the same answer that my vector is giving. Let us find out the magnitude in either of the cases. What did we get earlier? Side square plus side square. You remember the Pythagoras theorem method? In there, one side was 2, the other side was also 2. So it could give me root 8 as the answer. So that was my answer in the previous case. How will I find the magnitude of this vector? Let us go and refer my previous lecture. I have told you how to find magnitude of a vector if it is in this form, ai cap plus bj cap. What is its magnitude? It will be equal to square root of a square plus b square. Find the magnitude in this case. It will be square root of 2 square plus 2 square, again root 8. So it is not giving me extra information as of now. Even by the previous method I could get the same answer. Then what is big deal about vectors? It is giving me the direction in which this displacement has happened. That is an additional information it is giving me which the previous two methods could not give. And how is it giving me that? Notice this 2i cap plus 2j cap. Try to refer my previous lecture. What did I say in there? The direction is given by tan of theta equal to b by a. Right? So 2 by 2 tan of theta is equal to b by a. And no other previous methods could give me this direction. Now I am getting my direction as tan theta is equal to 2 by 2, which is 1. Refer our table of trigonometric functions. Which theta does correspond to tan theta equal to 1? It is 45 degree. And that is why I get theta is equal to 45 degree. So I get my magnitude. Of displacement. And I also get my direction of displacement. So that will be a complete description about this displacement vector. So we not just need a magnitude, we need to express the direction also. This I cap j cap method, it can really give me my magnitude as well as direction both. And that is why it is more important to learn this. Okay, now this was very simple numerical where you had just 45 degree angle, both position coordinates were 2, 2 or 4, 4, so they were alike. So this is a very preliminary level of numerical, but if any numerical comes which has some other sort of these numbers, you can still implement the same method and get an answer. This is an effective method to get an answer where you get direction as well as magnitude for the displacement. Now, this is only about the displacement. We wanted to find something more as well, right? And what was that? We wanted to find distance, displacement, average speed and average velocity, right? So, our distance comes out as 2 meter plus 2 meter, that is 4 meter. How much is our displacement? It is root 8 meter. For your information, how much will this be? It will be 2 root 2 meter. When you learn about surds, you will know how to simplify root 8 into 2 root 2. In mathematics, you will learn that. Now, 2 root 2 will be 2 into 1.41 because that is the square root of 2, which will be equal to 2.82 meter displacement. So, as expected, and what is the angle? Angle is 45 degree with x-axis. So, magnitude and angle, that means direction. So, as expected, our displacement is less than the distance. This will always be true. Our displacement, you go for 1D motion, 2D motion or 3D motion. Irrespective of that, your displacement will always be less than or equal to your distance. Okay. They will be equal only if the distance is covered or the path length is only in one direction and it's on a straight line. So you have distance equal to displacement. But in all other cases, your distance is going to be bigger than the displacement, or displacement is going to be smaller than the distance. So this is about your distance and displacement. What about average speed and average velocity? Now you are going to find them. I am leaving it up to you as a homework because I have already found distance and displacement. What is left is dividing them with their time. So for x directional motion, I had given you speed with which it is covered. You also know the distance in y direction, I mean. So y direction I have given you speed, y direction motion I have given you distance. So divide distance by speed. What will it give you? Time, like you did in your 1D motion. Same way you can do it with horizontal motion. What is the distance? 2 meters. What is the speed with which it is covered? The speed was given. You divide them, you get time. So T1, T2, you get 2 times, right? Add them up. That is the total time of the motion. Now that total time you have to put in the denominator of distance. You will get your average speed. That total time you put it in the denominator of the displacement, you will get the average velocity along with its direction will be same, which is same as the direction of the displacement. So put that total time T total in here, you will get velocity. Put that T total in here, you will get your average speed. So average speed and average velocity is your task I am giving you as a homework. Now let us go towards a little bit difficult numerical. A little bit. So in there what we will do is same our xy plane. Now our particle is somewhere over here. Okay. Its initial speed. So let me first give you its location. Say it is 1, 1. Its initial speed is u equal to I cap plus j cap. That means I should actually draw it at 45 degrees because I cap and j cap, since both are equal in magnitude, it will look something like this. This is its initial speed. It is I cap plus j cap. And then it is subjected to an acceleration. This particle is subjected to an acceleration in horizontal direction. Acceleration equal to 2 I cap meter per second square. The units will stay same. Here the unit is meters per second. So your initial velocity, the particle is initially going in this direction. Understand the physical situation. What is happening here? The particle is moving in this direction. Currently at time equal to 0, it is at location 1, 1 and is trying to go in this direction. But what is acceleration doing? It is dragging the particle in this direction. So what will happen to the particle? Since try doing this, try to move a particle in this direction, but don't drag it anywhere. It will pass as if it is going at 45 degrees. Now what you do is provide an additional drag to the particle, provide an additional push to the particle. What will happen? It will go in relatively horizontal direction because this acceleration is increasing its velocity in x direction. It is not doing anything in y direction. So to solve this numerical, you have to understand how a 2D motion is analyzed. And there is a small principle that you should always keep in mind while analyzing a 2D motion. What does the principle say? 2D motion. So do this. Analyze a 2D motion as 2 separate 1D motion. Very simple principle. 2D motion, you analyze them as if they are 2 separate 1D motions. Now you know how to analyze a 1D motion. You have to find, for 1D motion, you have to find 5 parameters. U, V, S, A, T. You find these 5 parameters in one direction. You find these 5 parameters in other direction and treat them as if you are solving 2 different problems independent of each other. X directional motion will happen on its own. Y directional motion will happen on its own. X directional motion will have its own initial speed, final speed, acceleration, time and displacement. Y directional motion will have its own all these 5 things. Analyze them separately. Now you will ask, then what? It's as good as analyzing 2 different 1D problems. Then where is the linkage? How do we understand whether it's 2 1D problems or it's a single 2D problem? The linkage lies in time. You know, when a particle moves from one location to other location, its x velocity, acceleration, displacement could be different. Its y velocity, acceleration, displacement could be different. But when does it start from here and taking some random path, when does it reach here? Those 2 time instants will always remain the same. Its x motion and its y motion will begin and end at the same point of time. Understand this properly. It's x motion and y motion. See, this motion has 2 components, right? It's moving in x direction as well as it's moving in y direction. Meaning its x coordinate is increasing, its y coordinate is also increasing. So it's a 2-dimensional motion. When does its 2-dimensional motion begin? When it is at this instant. When does it end? At this instant. So the difference between the 2 instants, that is the total time of the motion, will remain same irrespective of you are analyzing x or y motion. So that means the time acts as a bridge between the 2 motions. So write SUVAT in x direction. Write SUVAT in y direction. Only time and time should be used common between the 2, and that forms a linkage or the bridge between x and y motion. If you do this way, so basically this will be Sx, Ux, Vx, Ax, T will remain as is. It will be Sy, Uy, Vy, Ay, T will remain as is. If you do this way, you will not find difficulty in solving any 2D problem. Let it be this problem or a projectile motion or a circular motion. In any kind of 2-dimensional problem, follow the same principle. Then you won't have to remember any formulae, you won't have to remember any tips or tricks. So let us try to do this problem using this method. We will find x directional motions parameter. Okay. So the acceleration is applied to it, and I should give 3 parameters to you, right? In any kinematics problem, you should know 3 things, not 2 things. 2 is what you can find, 3 is what you should know. So I have given you initial velocity, I have given you acceleration, I also will have to give you something more to it. So let us say I give you the time for which this motion has been happening, because you know with what velocity it began. You know what is the acceleration given to it, but you don't know for how much time is it going to continue, because if it continues for say 1 second, then particle will be here. If it continues for 5 seconds, particle will probably be here. So let me give you that time is 4 seconds. So for that much time you have to find particles. What do you have to find? What is the final velocity of the particle? Velocity bar. So I am talking about I cap and j cap components both, because in the initial velocity I have given you both the components. So final velocity, don't give me as if it's a number. Give me in format of I cap and j cap. Also, what more can I find out? I can find out what is the total displacement of the particle, but that will be very simple, because it will be only difference between the final position and the initial position. The initial position being 1, 1. So when I say displacement, what you actually need to find out is your final position. Once you find final position, you can find the total displacement. So let me write it that way. Give me final x, y coordinates of this point, because once you get that, you have x2, y2, you have x1, y1. Just subtract them, square them, add like in the previous distance formula, and you will get your total displacement. So that's not a big deal. Now let us analyze x motion. So this is the way you are going to write anywhere in your notebook or wherever you solve this problem. You have to write it this way: separately x motion, separately y motion. In x motion, write SUVAT. Or you can even put the suffixes. For t, you don't need to put anything. So Sx, Now Sx, that is displacement in the x direction. So basically this motion analyzed only in x direction. Now that I don't know because I am supposed to find this x coordinate, right? So I don't know this. What is ux? So u velocity in x direction. Now you know that whatever is with I cap, that is in x direction. Whatever is with j cap, that is in y direction. What is with I cap? It's 1 I cap plus 1 j cap, right? I cap plus j cap it means 1 I cap plus 1 j cap. Had it been 2 I cap plus 2 j cap, I would have written it that way. It's I cap plus j cap. So it is 1 I cap plus 1 j cap. So how much is velocity in x direction? It is only 1 meter per second. See, now I don't have any I cap or j cap because the problem is already split into two different directions. Once I say that I am going to analyze x motion, I don't need to put any suffixes like I cap and j cap because it is only going to be in x. That means it is going to be I cap related motion. So I don't need to specifically put I cap in there. What is final velocity in x direction? That is unknown because it is to be found out. What is acceleration in x direction? How much is it? 2 I cap. So notice here itself that there is no j cap component to it. That means there is no acceleration in vertical direction. Whatever is there, it's only in horizontal direction. Acceleration is 2 meters per second square in x direction. So 2 meter per second square. I don't need to put extra I cap in there for obvious reason. Time. Now as I have said, time is the linkage between x and y motion. It is going to be same for both. So how much is it? 4 seconds. Now solve it as if you have a single simple one-dimensional problem. What do you have? U, A and T. What do you need to find? Sx and Vx, right? So let us use equation probably V square is equal to U square, but that wouldn't be useful because we don't have S and that equation involves S. So which one shall we use? S is equal to ut plus half at square. So how much is it? U is 1 into time is 4 plus half into acceleration is 2 into t square is 16. How much is it? 4 plus 16. So how much is it? 20 meter. Now that is my displacement in x direction. Do not confuse it with the x coordinate. What is it? It is my displacement in the x direction. That means difference between the x coordinates is 20 meter. That means if initial x coordinate is given to be as 1 meter and the difference between the two is 20, that means this has to be 21. If you do not understand it this way, let me put it in the form of equation. What is 20 meter? It is my displacement in the x direction. What is displacement defined as? It is defined as change in the x position because that is x displacement. So change in the x position. What is the change in the x position? It is final position minus initial. What is final position? X unknown. What is initial position? 1 meter. Now just put this 1 on the other side. What will you get? X as 21 meter, right? So this x coordinate I have got it as 21 meter, right? Now same way I am going to leave it up to you. Same way you have to do for y direction. But let me first find velocity's x component also. Once I find that, y is totally going to be left to you. So let me write y motions velocity calculation. So not y motion, x motion's velocity calculation. Same x motion, but I will do velocity calculation. So again in I cap direction. Now what all data do you have? Same data. I just rubbed it off, so I'll have to write it again. So Sx, now you have it, but even if you didn't have it, it was possible to find velocity. So SUVAT. What is your Ux? It is 1 meter per second in I direction. Vx was unknown. That is in fact something we need to find. Acceleration in x direction is 2 meters per second. And time was given as 4 seconds, right? Now which equation will you use for finding V? Simple. V is equal to U plus AT. In fact, I should have used this earlier. I would have got velocity by now. So what is my velocity? U is 1 plus acceleration is 2 into time is 4. So how much is it? 9 meters per second is my velocity x, that means final velocity in x direction. How will I write it as? 9. So I will write it as 9 I cap plus, now the j cap thing you have to find something into j cap. Now I will not tell you how much is it going to be. You will have to solve by writing SU, VAT, apply equations. Just take care that acceleration in y direction is absent because there is no j cap component. So you'll have to put 0 because no j cap means 0 j cap. So put acceleration as 0 in y direction, solve for y coordinate, that is y displacement, and find then y coordinate using the same logic. Also find this box that will give you y component of the velocity. This is the way the problems in two-dimensional motion are analyzed. Now in the next lecture, we will see how using the same logic we can solve simple problems like when you throw you have some ball with you and you throw it, right? When you throw it, it goes as a projectile. Imagine that you throw a ball on the ground. It goes to your friend's hands like a projectile. Now how does that happen? How does your brain calculate with what velocity and what angle should you throw it towards your friend so that it exactly or almost exactly lands into your friend's hands? Because let us say your friend is standing at 100 meters from you or maybe 50 meters from you. You take that stance and then throw the ball towards your friend with some angle. But if he is standing, further more distance, you take a different stance. If he is standing very close to you, you just throw it to him. Right? So how does your brain decide what stance to take, at what angle to throw it, and with how much force or how much velocity to give it? How does your brain calculate all that so that the ball reaches at the exact location? How does it do that? For how much time is the ball in flight? For how much time does the ball stay in air? That also we can calculate. Then when you throw, what is the maximum points height at which the ball reaches? That means your ball follows this trajectory, right? There is some point where it has maximum height. What is that point? Now, if you want that ball to reach your friend's hands, you can do it by several ways. But what is the most optimum way of doing it? Basically, at what angle and at what velocity should you throw it, so that with minimum energy spent from your side, still the ball reaches to your friend's hands. Because if you change the angle, the ball can still reach into your friend's hands, but you will have to make different velocities for that. So we'll come to all that. But remember that we can find optimum velocity just by using kinematics, the velocity at which you can use minimum energy. You will get least exhausted, but still the ball will reach into your friend's hand. You can find all that. Then probably in the next lecture, we will analyze the circular motion. So when something moves in a circle, what is the speed with which it moves? What is the acceleration of that object moving in a circle? Then we will analyze different things. If it starts accelerating, basically its speed starts increasing. You see a fan, the fan is switched off and you turn on the fan. What happens? Its blades start increasing in speed and then it reaches some constant speed. How much time does that take? What is the acceleration with which it accelerates? We will see all these things in this two-dimensional motion in the next further lectures. Thank you.